Hello, good evening, everyone. My name is Aaron. I'll be your MC for the evening. This is the Chippy main meeting for October. And I'll go through a brief little introduction of Chippy, and then we'll get into the main event. Well, again, welcome everyone to the Chippy main meeting for October here on YouTube, virtual meetup. We just have a couple house cleaning items to go through here before we get started. As you can see, Chippy has a code of conduct. We do expect our community to behave in a professional manner to everyone else in the community. If you don't know how to do that, please do check out the code of conduct. If you have any questions or feel like someone has violated the code of conduct, please reach out to Chippy, the board members, or the conduct committee, and we will address that appropriately. What is Chippy? Chippy is a Python-focused community that started in 2003. Our current members are myself, Chris, Heather, Joe, Kevin, and Zach. We do have several initiatives to help out the Chippy community. One is the project night. That has been a lot of work around the Chippy website, chippy.org recently, as well as code reviews and just general items that people want to work on at project night. Kind of bring your project, bring questions, and we go from there. Buddy mentorship, that is available at chippymentor.org. We match up mentors with mentees. You can sign up to be either one. Please be specific in the skill set that you have or want to acquire to make sure that you're paired up with the best possible mentor or mentee. Python lunch break is another initiative over lunch. And then if you're looking for jobs, we do have a job board on chippy.org. We have several postings right now. So if you're looking for Python work, please check out chippy.org. Several special interest groups for Chippy: finance, data, web development, algorithms, and the entrepreneurship group. You can find more information about those again on chippy.org, or I'll give you a couple other ways to contact us here shortly. Upcoming Chippy events. The virtual project night will be happening Thursday, October 21st. And then on November 11th, we have the next main meeting. That will be a special edition. We are going to do Python-powered business. We'll have several people in the community here talking about how they use Python in their businesses, what the needs are for industry right now for Python, and if they have any positions that they are looking to fill. Q&A, speakers may have a open up for a quick question and answer session after their talk. If you have a question that you'd like to ask the speaker, please do type your question into the chat. I will read that question off and let the speaker address that question. Do note there's kind of like a 10-second delay between the stream on YouTube, so it may not be kind of instantaneous. Where to find us, Chippy? Easy to find us. We're on Slack, we're on Twitter, and of course we're on chippy.org. So again, here's the address for our Slack, our handle on Twitter @ChicagoPython, and the website chippy.org. There is a contact form. After the meeting's over, we will hold a brief after party. People can hang out as long as they want. That is at http://chippy.town. Really kind of a cool virtual meetup space. As you get closer to people, the avatars in on the floor plan, then your audio and visual go live with those individuals. As you move away, it's not available. There's breakout rooms, there's places to sit and hang out, chat. So if you're interested in kind of like doing the normal meetup thing in a virtual space after the talks, please head over to chippy.town. And now I'm going to introduce one of our proud sponsors of Chippy, Ari from JFrog. Ari, would you like to talk about your sponsorship of Chippy and your raffle tonight?
Absolutely. Thanks so much, Aaron. I really appreciate it. Hi, everyone. My name is Ari Waller, and I am the Meetup Event Manager for JFrog. And we're really excited to be a sponsor for 2021 for Chippy. I'll share just a little bit about who we are. JFrog is the DevOps software company known best for Artifactory, which is considered by many to be the gold standard for managing your Python artifacts and dependencies. Besides the raffle I will tell you about shortly, JFrog wants to offer all attendees tonight a free cloud version of Artifactory for the Python development community. No credit card is required, and it's not a trial version that runs out. You can use Artifactory as a single access point for all of your proprietary libraries and remote artifacts and third-party resources, including PyPy. And because Artifactory fully supports standard Python tools such as pip and distutils, it transparently replaces your repositories to boost productivity when developing with Python and open source libraries. And also, if you're working with Docker, you can use Artifactory to manage both your Python packages and Docker images, as it's capable of functioning as a pull-through cache for Docker Hub. And because of JFrog's partnership with Docker, you'll be exempt from their rate limits on pulls from free or anonymous accounts. And one way to get this is to enter the raffle tonight that you see in the slide behind you, or behind me rather, to win one of 3 Adafruit PyGamer starter kits. This is a really cool contraption. It's open source and runs Circuit Python, so you can make your own games. You enter the raffle with the QR code or the bit.ly link that you see, and also Aaron's going to drop it into the YouTube chat in just a few moments. When you enter, you'll have the opportunity to opt in to receive a link to your free cloud subscription as well. And if you don't want to enter the raffle, for some reason you don't want to make any really cool games, that's cool too. There'll be a link also on that page for you to go to directly to the free cloud version I just talked about. Now, 3 winners. We're going to be actually selecting 3 winners that are going to be possibly winning with 2, and we're going to select them within 2 business days. And then we are going to share the name with the lucky of them. Excuse me. We're going to share the names of the lucky winners with the whole community. We want to make sure that first they'll accept the prize, and then we'll be happy to share it with everybody. So with that being said, again, I want to thank Aaron and really the whole Chippy community for just being so awesome and allowing us to be part of everything going on here. So thanks again, Aaron.
No, thank you, Ari. We're really happy to have you on. You and JFrog both on board as sponsors. So you do a lot of good stuff for us. So thank you for that.
Appreciate it.
All right. Okay. And then with that, tonight's schedule, we have 2 great talks planned for this evening. The first will be Mega, who will be telling us how to speed up our builds by using asynchronous tests. After that, we'll take a very brief Q&A probably, followed by a little intermission. And then Shashank is on deck after that. He will be telling us how to use Streamlit to build financial dashboards. So with that, I'd like to introduce Mega. Nice to meet you, Mega. Thank you for taking the time to give a talk tonight at the main meeting. Before you get started, though, would you just mind telling us a little bit about yourself and how you came to be involved with Python and the Python community?
Sure. I'm Mega Machado, and I am a platform engineer at Nielsen, and I help develop features for and maintain our data science platform. My introduction to Python was originally from the scripting side of things. I was working on POC type projects and for ETL pipelines, and Python was just awesome to get started. Then I started working on Nielsen's data science platform itself as an end user. My roots are as an ETL engineer. So I started working on Nielsen's data science platform, and I really liked the platform. I liked the Python ecosystem. And then I got an opportunity to work on the platform team itself, and that really turbocharged my Python journey. I got introduced to Chippy through Joe Jasinski, who is my teammate and is a treasurer and MCs the Chippy meetings every now and then. And I actually gave my first public talk on Python sometime a couple of years ago, I think. And I just found the experience to be so positive and the community so welcoming that when Joe mentioned that they were looking for some speakers this month, I thought I would talk about asynchronous PyTest, which is something that I used in my job recently to speed up our builds.
That's awesome. That's really good. That's great. Looking forward to your talk. Well,
So, okay, just checking that my presentation is visible.
I don't see it quite yet. I'm going to stop my screen share and see if that helps. Right.
I'm going to try this again.
All right.
How about now?
Oh, I have to edit this stream. I'm so sorry. There we go. Sorry, everyone. It's my first time hosting tonight. Joe usually does this, and I'm filling in as he's on vacation. All right, take it away.
Cool. So faster builds with asynchronous PyTests. So I'm going to talk about speeding up builds in the context of a CI/CD pipeline. The basic steps in a CI/CD pipeline are, you plan what feature or bug fix you're going to work on, and then you write the code for it, commit it to a source control repository, and then you have some type of CI tools like Jenkins or GitLab CI that kick off builds, and then they run a suite of tests. And if all the tests pass, then the build is prepped for release and then deployed for use. Now, the portion we're going to focus on is the continuous integration piece of it, which is the code, build, and test. Now, very rarely do all tests pass at the first try. So it takes a few iterations of code, build, and test to complete a feature. So let's go look at an example test suite that I put together for this demo. So here I've got a test suite written in Python, and I've got some very basic tests here. All I'm doing here is, asserting true. It's not really testing anything. But I've introduced some weights in all of these tests using sleep. And I'm going to kick these tests off with PyTest. And let's see how long it takes. So it's executing the tests in the order that I've defined them in my test suite. And it's executing them one after the other. And the 6 tests took about 9 seconds to complete. This is fine in my trivial example where I've got just like 6 tests. But in an automated test suite, you might have tens or even hundreds of tests. And in that case, waiting 15 minutes, 20 minutes, 30 minutes, or 2 hours for one iteration to complete to check if your feature works as expected gets really tedious. And it also gets very hard not to reach for the phone and browse Reddit. So can we do better? So here's a comparison. On the left is, the way our test suite is executing now, and it's going sequentially. But what if we fired it all at once? So then our test duration would only be as slow as the slowest test duration. So in our case, test 3 takes 3 seconds. So our total time would be 3 seconds, which is a huge improvement compared to 9 seconds, only a third of the time. Now, this is great, obviously, while you're developing features because you're able to get into a state of flow. You're doing this REPL quickly and you're having a really good time and the world is an awesome place. But it becomes even more apparent when we have to hotfix something in an emergency. So then, we're under the gun and we want to respond as quickly as possible. And having a test suite that completes quickly means that we can respond to such situations faster and we are not working crazy long hours to get the fix in. So what options do we have available to us to kick them all off at the same time? The diagram at the top describes our test suite the way it is now. There's one process that is running, and it's running the test one after the other. It fires off the first test, waits until it completes, then fires off the next test, and so on. And it takes a long time. Parallel execution, which is the second diagram, is when there are multiple processes. So process 1 executes the first test, waits for the result, and when done, it shuts down. Process 2 starts the second test, waits for the result, shuts down. Now, the second process didn't have to wait for the first one. So our tests are going to complete faster. In the asynchronous model, which is the third diagram, there is only one process. The process internally uses an event loop, which is the main coordinator of tasks and their results. So when a task encounters a blocking operation, such as sleep or an IO call or similar, it hands control back to the event loop. The event loop adds a placeholder for the task's result and moves on to starting the next task. As the task complete, they notify the event loop that they're done. So in this model, the process is not sitting idle when a blocking condition is encountered. Parallelism is best suited for CPU-intensive operations, and asynchronous execution is best suited for I/O or network-dependent operations. So for example, you're making an HTTP request to an outside service. So how do we apply these concepts to our test suite? Do we have to dick around with multiprocessing and multi-threading? How do we go about doing that? Now, the great thing about the Python ecosystem is that there are so many projects available that we can pick up and use. So we're going to use PyTest plugins to help get us set up and running as quickly as possible. So there are 3 plugins that I'm going to talk about today. The first one is PyTest XDist. This is a super simple plugin, easily installable with pip. Just pip install PyTest XDist, and then when you kick off your PyTest, when you invoke your PyTest command, you pass it some command line options to select how many processes you want it to run, and that's it. PyTest Parallel is multi-process and multi-threaded, which means it kicks off multiple processes, and within each process, it kicks off multiple threads. So you get parallelism and you can run a bunch of tests concurrently. Both of these options are good for CPU-intensive tests, and they do not require refactoring your test suite in any way, but they do not do well for I/O blocking operations. So this scenario comes into play when you have a microservices-based architecture and your tests are checking if these services are reachable, if they're giving you the right response, etc. So in this case, you're firing off a request and you're waiting for the response to come back. And for the time that you're waiting, your process is blocked and wasting resources. And that's where PyTest Async IO Cooperative is a good candidate. It is single-threaded, just one process, and it is asynchronous, and it uses Python's Async IO module under the hood. And this is the one that I'll be focusing on because it's not so simple as simply installing it and invoking a few command line options. We do need to refactor our tests so that they are asynchronous. Let's go back to our test suite and see what that refactoring would look like. So the first thing we have to do is we have to add this decorator, to mark this test as an asynchronous test so that the plugin knows that it needs to run this asynchronously. And the second thing we need to do is convert all of our test functions into asynchronous coroutines. And that's done by using the async and await keywords. And we also need to switch out any synchronous functions with asynchronous ones. So in my original test suite, I was using sleep from time, which is synchronous. And here I've switched it out to use async IO's sleep function. So this is the first level of refactoring that needs to be done. Now, let's say that you have a test that's using some third-party function to do some type of setup that your test needs. So in my test suite, in my synchronous test suite example, here I've got test 5. So it's doing some arranging by calling this setup compute from this module called bar. And it's using that value to actually test the function that we actually want to, which is this compute square, and then it's asserting that the result is what is expected. So when we want to refactor such a function, one option is we could go into the bar module, find the setup compute function, and convert it into an asynchronous function. But if it is a third-party module, we may not be able to modify it so easily. And there may be other Python programs that we have that use this function, and switching it to asynchronous could likely break those programs. So what we can do in this case is we can use the lower level APIs of async IO to interact with the event loop directly. So what we do as part of our arranging is we get the current running event loop, and then we add our function to that event loop and have it execute in that current event loop. And that way we can await it. So we didn't have to refactor this module at all. We just had to write a couple of lines of code to add this function to our event loop. And then we can run our test and so on. So let's see what kind of improvement this does for us. So here we can see that the tests completed in 3 seconds. As we expected, it took as long as the slowest test duration. And another thing we can see is that the tests did not execute in the order that we wrote them. So test 6, which is the fastest, finished first, and then so it goes from the fastest to the slowest. So in my project at Nielsen, we use PyTest to run end-to-end tests to validate features and ensure that there's no regression before we deploy a new release. As I mentioned, our product is microservices based, so these tests were making calls to the services. So our slowest test suite took about 3 hours to complete, sometimes longer. And by converting it to asynchronous tests, we brought it down to less than an hour. Several developers were very happy, I may add. The other great thing about Async IO Cooperative is because we are marking tests individually, we can pick and choose which tests we want to convert to asynchronous and which we want to leave as is. So you can have a mix of async tests and synchronous tests. So in the context of my project, our test suite had a bunch of tests that could not be easily converted to asynchronous because they were using shared fixtures, or they were using some mocks, things like that. So we didn't have to refactor our entire test suite. We just picked the ones where we could very easily convert them to async functions. And just with that, we were able to get a huge payoff. Now, async IO is not easy. Of course, it gives a lot of benefits, but we do have to keep these caveats in mind. So sharing is not a good idea. So no mock.patch or any shared resources. But then again, if your tests are using shared resources, you may want to look at them closer anyway to remove those dependencies. And there's also limited PyTest annotation support. So PyTest has several annotations like pytest.mark, pytest.skip, pytest.skipif. So skipif is an annotation you can add to skip tests based on certain conditions in your environment. Async IO Cooperative does not honor that. But in most cases, it is fairly straightforward to convert them into asynchronous tests. And a lot of these are also discussed on their GitHub page. So you pip install async.io cooperative, and then fixtures, of course, have to be converted to asynchronous functions. And then if you have any mocks and shared resources, you can use locks, and there are examples here for how you may go about doing that. So that was my brief talk. And finally, Nielsen is hiring. We are hiring application developers. We're looking for site reliability engineers. And if you go to our careers page and search for North America and Python, there are tons of openings. So feel free to apply.
Well, thank you so much, Megha. That was a really great talk. I can see you much better now. So, how did you, just to kind of maybe quick kick off the questions here, how did you go about finding the tests that you wanted to mark or make asynchronous in your test suite? Are there metrics available like in PyTest to find out which ones are like taking the longest time?
Yes, you can display this. Oh, I'm getting an echo. Okay. So you can have PyTest print out a summary of your test results so that it also prints out the duration. And that's one way to get started on which are your slowest test durations and would they benefit from being parallelized this way. The other way is to look at what tests are actually doing. There may be whole batches of them that are making this type of, request calls. So requests.get, requests.post, those type of calls. So if they're doing that, they're a good candidate for running asynchronously as well.
Okay. Cool. Now you said that like some of the like mocking in general is a bad idea with the asynchronous tests. Can you still do like mock on the ones that you don't make asynchronous, like the ones that you do leave synchronous?
Absolutely. So tests that you don't mark with the async.io cooperative mark, the other tests will behave exactly like regular synchronous tests. So you can use the full suite of PyTest features.
That's great. It sounds like it's a really powerful technique to speed up your testing. And we did have a question from the community, and this person wanted to know, what is the name of the company you work at, and curious about the open positions, if you wanted to talk about that a little bit.
Sure. I work at Nielsen, the ratings company. They have been providing ratings for TV shows in the past and recently switching more to streaming. And you can go to nielsen.com, www.nielsen.com, and go to the careers page and apply these filters based on what type of position you're looking at and in what location you're looking.
Okay. Very good. Thank you very much. Are there any other questions out there from the community? I'll give it maybe a couple seconds just because of the delay. But I'd like to thank you very much for a really great talk, very informative, and I think I learned a lot from that tonight. Thank you.
It's been a pleasure. Thank you, Aaron.
All right. I don't see any other questions coming in, so I think we will take a brief intermission. Sound good? Thank you very much for joining us. All right, everyone. With that, I think we'll conclude the short break here, and we'll introduce Shashank, who's going to give us an overview on Streamlit and financial dashboards. Hi, Shashank. How are you doing this evening?
Hi, Aaron. I'm doing good. How are you?
I'm good. Thank you very much. Before you get started with your talk, could you give maybe a little bit of your background and how you got involved with Python?
So I started working in data science with R. That was the standard language that was used maybe like 3-4 years ago. And eventually Python took over with the world of machine learning, and that became the primary language. And so I switched over to Python, and that's how I got into Python. And currently I'm working as a data scientist at Grainger, Chicago.
Oh, that's great. So how did you like the transition from going from R to Python for data science?
I mean, initially it was not fun, but eventually when I started using it, I saw a lot of value in it. And that's the reason why the world of data science moved towards Python, that it's a general purpose programming language, and it's much easier to productionalize it compared to R. And as time has passed over the past 3-4 years, the libraries have gotten so good that, it is the main language for data science now.
Yeah. Do you ever call from Python into R for anything still these days, or is this all pure Python from?
I mean, you have that option of being able to use R and Python together, but personally, I don't really ever do that. But I know folks who do that, but I try to stick to Python. Yeah, that's what I do.
All right. Well, with that, let's kick off your talk, and I'll drop off here. Thanks, Shashank.
Okay. I hope my screen is visible. Okay. So I'm going to talk about 1 minute. There seems to be an issue. Okay. So this is one of my personal projects, building a Streamlit dashboard using IEX API. So first, I'll talk about why I built the app, and then choosing the right source for finance data, and finally, how do we build the dashboard using Streamlit. So objective of this app. So for quite a few years, I've been investing with my friends in the stock market, but our approach would be to just invest in index funds. But as we got more familiar with the stock market, we wanted to invest in specific stocks. And we had a set process in terms of how we picked out stocks. And we decided that we wanted to automate it and build something that is more advanced, that would recommend the stock to us, build an app that could do that. So since the language I use at work is Python, so I decided that I'd build an app in Python that shows the fundamental data of the selected stocks. It would calculate a few metrics to help us choose which stocks to invest in, and eventually build a model that recommends stocks for investment. So in today's, right now, in the current state, we've been able to do the first two. And this app was built with the help of my friend Envi Arvind, who supplied most of the finance knowledge, because I brought in the technical know-how of programming, but I am not as familiar with all the financial ratios and everything that is required to decide which stock to invest in. So the first issue whenever you build a financial app is which data source to use. And since it was a personal project, initially our thought was just to be able to use something that was freely available. And the easiest option for that was web scraping. For example, there are websites like Yahoo Finance and Finviz, which have this data available in a tabular form, and you could easily scrape that. And so that was our initial thought. And so the pros for that is that all the data that we require is available, any kind of historical data, all the stock data is available, and it's free. But there are obviously limitations to scraping. There's, first of all, you could use a package like Beautiful Soup and do it, but there's always the issue of specific HTML coding that you have to deal with, and then there are various other nitty-gritties that you need to deal with while scraping, and which makes it very time-consuming to be able to scrape that data and then clean it up and get it in the exact format that you need. So this first approach that we took didn't look like a good approach. So the second option was trading APIs. And trading APIs, you must have heard of Robinhood, TD Ameritrade. A lot of these are available. You have good documentation for those. There is a generous number of API data pools allowed, and it's free if you open an account with these brokers. But it's mostly focused on real-time stock data and technical analysis, and it's tailored towards building trading bots. And our approach was towards long-term investment. So we wanted some fundamental data, historical data, and that wasn't available through this data source. So finally, we decided that we'd have to invest in something, and there's where the third option comes in, stock market APIs. The example is IEX Cloud, Polygon.io, and we found out that for these stock market APIs, you have all the fundamental and technical data available, historical data going back a few years, and you have really good documentation for these APIs. So instead of trying to spend most of our time in getting the data, we decided to go with this approach. And it's obviously paid. That is one of the negatives of it. But we chose IEX because it's relatively inexpensive at about $10 a month, and it provides all the required data that we need. And the good part is you don't have to calculate a lot of these ratios. It's already done by them, so you can just pull them and use it. So based on our analysis, and we decided to go with IEX Cloud. And so I'll just go over a few sets of some basic data pulls through IEX and show you why I feel like it's really good and it's really easy to do. So you can pull JSON data, and you can use simply the request package. And the great part about it is that it's just a simple URL. In this function, as you can see, there's a token. So that's the API token that is provided to you by IEX. The symbol, that's the symbols or stock symbols. So like MSFT for Microsoft, for example. And the environment, third variable that we have to pass is production. So the environment, sorry. So that's between, you have two options in terms of APIs. You have the production API and you have the sandbox API. So you could use the sandbox to test whatever data you're pulling and whatever calculations you're doing. And once you're done, then you could use the production API, because obviously this is paid and your credits get used up. So in terms of pulling the data, as you can see, it's really easy. It's just a few lines of code and you have financial data accessible to you. So here we're just initializing it. Now, obviously, to pull the data, you'd have to there are several different functions available on the IEX API. I've just put in one small example here. Get balance sheet, this is the function I've created. And as you can see, you put in the base URL from the last slide. So I'll just go back to it. You either use the production or the sandbox URL, and that goes in here, and then you pass the symbol, and then after that, the function that you need along with the parameters that you want to pass. And you get, in return, you get a JSON, and you can easily convert it into a pandas data frame, for example, and do whatever calculations you need to do on it. So it's that simple, pulling data. And in terms of what kind of data is available, you have a host of you have stock fundamentals, corporate actions, crypto, commodities, anything that you can think of is available on this. So this is one of the recommended APIs that I would say to use for financial data. There are several others are also available, and most of them have this data, all of these different kind of data. So the first part of obviously building a financial data dashboard is pulling the data, and that was made easy thanks to this API. Next step was we wanted to be able to build a dashboard that would show us the required data. Now, there are several packages available for it. Dash and Flask are quite famous, And Streamlit has been around for a little more than a year, or if I remember correctly. Recently, they released their 1.0 version. So the best part about Streamlit is that it has been built ground up to make data apps, data web apps. So it's focused on that, and they've made it really easy. And some of the reasons why I really like it is that it embraces Python scripting, so no HTML knowledge is needed. So that's a great thing. Second, less code is needed to create a beautiful application. So I'll obviously go into the code later on, but a few lines of code help you build apps really quickly. So that's great. There are no callbacks needed since widgets are treated as variables. So data is not reloaded again and again. That's a great thing. And there's also a feature of data caching, which simplifies and speeds up computation pipelines. So that's if you have data that you're pulling from an API, you don't need to keep hitting that API again and again and use up your credits, for example, or waste the round trip time. So that's another great thing about it. And there are like a number of demos available on the Streamlit website where they've built some great apps. So these are some of the reasons which made us decide that Streamlit is the best option for us. And so let's talk about some of the features of Streamlit. So there are several built-in widgets. I'll just talk about two of them, and which will show you how easy it is to build widgets, build the dashboard, using these widgets. For example, if you want to create a select box, it's as simple as this. The variable streamlit.select box, you just put in the text that you want to put as the title and the range for it and the steps for it, and there you have it. It's a select box. It's as simple as that. Similarly, if you want to create a slider, the same syntax. Call the function slider, put in the name, and then set in the minimum and max value, and put a default value and the step. So all the functions, all the widgets that are available in Streamlit are extremely easy to create. They're just one-liners, which makes it really easy. Some other great features of Streamlit are like caching that I talked about already. And this one is especially great, visualization. So Streamlit supports many visualization libraries, including Matplotlib, Altair, Vegalite, Plotly. So nearly everything you can think of. Even you can even load audio and video. So in terms of visualization, that's like the primary purposes of a data web app that you want to build. So it does great over there. And there are several more features that it supports, like Markdown, LaTeX, and much more. So I won't go into that. Obviously, you can check that out on the Streamlit website. Now, just let's look at a small example of the dashboard. And this will just show you how easy it is to create it. So you just import it. And if you want to, the first step I'm doing is I'm creating a sidebar where you can put in a text input. So which stock market symbol you want the data for. And the default value I'm putting in as Apple. Next step I'm doing is I'm using the IEX token, the API token, and initializing the stocks using the symbol value. Here I'm using Redis to cache whatever calls I'm going to make. Redis is another great Python package to cache whatever API calls you're making. And finally, this is the first screen that I'm creating where there's sidebar. I'm creating a sidebar with a select box which has these values, and I'm making the second value as default. And finally, the same value, I want to show it on the title. That's why I'm putting it here. So looking at the code, obviously it's easier to explain it if you can see the dashboard. So I'm going to open that and show you all the dashboard. Let me go back to the dashboard. Yeah. So this is what the dashboard looks like. So you remember I talked about a sidebar. So this is how the sidebar was created, and the default values that I talked about, overview, fundamentals, and DCF, you have present right here. And obviously there's more code, like in overview, I'm displaying the image. So this is what it looks like. And I'm running the Streamlit dashboard locally. So it runs on localhost 8501. So it just took 5 lines of code to come up with this web app. So that's the great part about it. Now, going back to the presentation, 1 second. Okay. So now the second part, like adding a screen. So you saw the overview screen, right, where we were seeing a logo. So again, to build that screen, if the screen is equal to overview, it's as simple as that. I'm checking for the cached key, if it's available or not. And if it's not available, then I call the stock.getLogo function to get the logo from IEX, and I save it in the cache. And here I'm using the sc.columns function to exactly place that logo in the center. And we use that value to display the logo. So I'll just go back to that dashboard. So another few, it took another like 5-6 lines of code to be able to do this, show you the logo, for example. If I change it to Microsoft, again, it's immediately pulling from the API and being able to display it. We've built some other function if we want to calculate the discounted cash flow, for example. It immediately pulls the data, calculates it, and show it to us. There's obviously some calculation involved in it, which shows you the value. But as you can see, it's so simple to build it. And I'll just call something again to show you how easy it is. And you see the value change to 107. So that's the beauty of Streamlit, that it's extremely easy to build any kind of apps. Yeah, so I showed you all the demo. So in terms of building web apps, it used to be much more difficult building web apps using Flask or Dash. I'm not saying it's hard, but it would take more lines of code. It would be more complicated. And so if we want to build any kind of web apps, I think Streamlit is a great alternative. You can build simple apps as well as complex web apps because it supports all kinds of visualizations, interactive content, audio and video, and it only takes a few lines of code to build good-looking web apps. And also, in terms of financial data, I know it would be best if it's available for free, but it's hard to find financial data for free. That's what we found out. And so IEX, for example, is a good alternative. Polygon is also a good alternative that you can use. But these sources are really good, and you can get all the data you need easily from the APIs. So this is just the start of our dashboard. We're planning to add much more to it and hopefully get to our final goal of being able to build a model that can recommend which stocks to invest in. That's about it. Thank you.
All right, thank you for that talk. It was really good. So glad that you brought up the topic of data and kind of the quality of data and the ease of using the API and the costs associated with that. That's really cool. I was also wondering what's been your best stock that you picked so far, or are you not to the point?
I think last year was, in terms of picking stocks, was pretty easy due to the pandemic. There was a very big dip, so most of the big tech companies, anyone that we bought has shown us like really good returns. It's been much more difficult to pick out stocks this year, for example. So.
Okay, cool. So, yeah, I just give a minute for some other questions maybe to flow in here. And we have one. Just curious, since you came from R, did you work with R Shiny before? And if so, what do you think about R Shiny versus Streamlit?
So I've worked with R Shiny, but I worked with it only a little bit. And I think Streamlit is just so much easier. I think it's the best. That's what my opinion is. I would say everybody should give it a shot once.
Okay, that's cool. Yeah.
Especially the thing about like everything is a variable, and there's a lot of good features in it. I would say that's the best web app right now. The dashboard development package in Python right now. Yeah.
And you haven't had to get your hands dirty with HTML or JS?
No, not at all. That's the best part.
That's really nice. It's really nice to just kind of code it and be done all in one language. Cool. All right. Maybe a fun question. So what do you use to develop in? Are you like a text editor guy, or do you have a full-blown IDE?
Right now it's VS Code, and I think that's what it's really popular.
Yeah, I use that too.
I think most Python users are now moving to VS Code, right? Is that your experience too?
I know a lot of people who are. Yeah, I think it's been more and more popular within the community. I mean, it's just like, using Vim and some of these other like text editors, and then you want to get to where you want to get with VS Code, and you can do it, but it's a lot more configuration stuff, and just the integrated package manager. I think is just, every time you go set up on a new machine, it's very fast anyways for me.
Yeah, and the transition is easy too, right? Your Vim shortcuts are available on VS Code if you're very used to them. So they've made it really easy.
Cool. Thank you. I don't see any other questions coming in, but lots of applause and stuff. Thank you again for being here. I'd just like to take a quick moment to thank both of our speakers for showing up tonight and giving these great talks to the Chippy community and making them available on YouTube for hereafter. We do get a lot of traffic after kind of the fact too, after the meeting. So I'm sure this will be viewed by a lot of people. Thank you very much, Shashank.
Thanks, Aaron.
Invite everyone to the after party. So with that, just a reminder, we're going to go add this back. We do have again this raffle from JFrog. If you missed that or on that earlier, please take some time to enter the raffle. They're giving 3 of these devices away. They look really cool. Wish everybody luck winning one. JFrog's been a great sponsor for us. And then also, I just want to remind everybody, we'll have a little after party at chippy.town now. This just kind of like a virtual meetup space. You can maybe meet some of the speakers or other people who are on the stream, hang out. This is also where we do our virtual project night, which will be held on Thursday next week. And with that, I will conclude the stream. I think I'll leave this up for just a moment so everybody can head over to chippy.town.